Important tips for solving problems on indices. 1. Index means how many times base is multiplied. The word indices is the plural of index. 2. Tips for solving problems on indices are given throughout the video, therefore watch the video till end. Do not skip any part.
INDiCES is a very easy technique. In this method, when we write 2 multiplied by 2 equal to 4, it is written as 2 raised to 2 equal to 4. When we have to write 2 times 2 times 2 is equal to 8, it is written as 2 raised to 3 equal to 8. This means that 2 is multiplied 3 times. In this case 2 is called as base and 3 is called as index. For writing 2 by 2 by 2x 2 by 2, 5 times we write 2 raised to 5 equal to 32. In this case 2 is base and 5 is index. Now let us understand laws of indices. We have seen 2 raised to 5 is equal to 2 multiplied 5 times equal to 32. But 2 multiplied 5 times can be split in 2 parts and can be written as 2 multiplied 3 times and 2 multiplied 2 times. Therefore, 2 raised to 5 is equal to 2 raised to 3 multiplied by 2 raised to 2. Similarly, 2 raised to 6 means 2 multiplied 6 times can be split in 2 parts and can be written as 2 multiplied 3 times multiplied by 2 multiplied 3 times.
Therefore, 2 raised to 6 can be written as 2 raised to 3 multiplied by 2 raised to 3. If instead of 2 if there would have been any base other than 2, still same logic will apply. For example, 3 raised to 7 can be written as 3 raised to 4 multiplied by 3 raised to 3. We can now generalize this rule as a raised to m plus n is equal to a raised to m multiplied by a raised to n. 2 raised to 5 divided by 2 raised to 3 is equal to 2 multiplied 5 times divided by 2 multiplied 3 times. Therefore it is equal to 2 raised to 5 minus 3 equal to 2. This is true for any value of base and integer as an index. Therefore rule can be generalized as a raised to m divided by a raised to n is equal to a raised to m minus n.
Similarly, if 2 raised to 3 is raised to 2, it means that 2 multiplied 3 times, and this product is multiplied 2 times. That is 2 is multiplied 6 times, therefore it is equal to 2 raised to 6. This can be generalized as a raised to m and it is then raised to n, then it is equal to a raised to m multiplied by n. On similar lines, it can be seen that following rules can be framed. Rule 4. A n to b raised to m is equal to a raised to m multiplied by b raised to m. Rule 5. A upon b raised m is equal to a raised to m divided by b raised to m. Rule 6. If a raised to m is equal to a raised to n, then m is equal to n. Rule 7. If a raised to m is equal to b, then a is equal to mth root of b. Rule 8. If a raised to m is equal to b raised to m, then a is equal to b. That is if for 2 different base variables, indices are same and they are equal, then those bases are equal. Rule 9. We know that a raised to m divided by a raised to m is equal to 1, but we know that a raised to m divided by a raised to m is equal to a raised to m minus m, which is equal to a raised to 0. Therefore a raised to 0 is equal to 1.
2 raised to minus 3 is equal to 1 upon 2 raised to 3 equal to 1 upon 8. In general, a raised to minus m is equal to 1 upon a raised to m. 4 raised to 1 upon 2 is equal to square root of 4. 8 raised to 1 upon 3 is equal to cube root of 8. A raised to 1 upon m is equal to nth root of a. Please note carefully, a raised to minus m is equal to 1 upon a raised to m. A raised to 1 upon m is equal to nth root of a. For example, 8 raised to minus 3 is equal to 1 upon 8 raised to 3, equal to 1 upon 512. 8 raised to 1 upon 3 is equal to cube root of 8, equal to 2. Note the difference. Square root of 2 square plus 3 square plus 6 square equals square root of 4 plus 9 plus 36, that is square root of 49 equal to 7. Square root of 2 square multiplied by 3 square multiplied by 6 square is equal to square root of 2 multiplied by 3 multiplied by 6, that is equal to 36. Be careful, for multiplied by a square raised to 1/2 is not equal to 4a, but it is 4 raised to half multiplied by a square raised to half. That is 2 multiplied by a equal to 2a. 1 upon 3 raised to minus 2 is not equal to 1 upon 9. But 1 upon 3 is equal to 3 raised to minus 1, and it is then raised to minus 2. Therefore it is equal to 3 raised to 2 and hence equal to 9. To solve 2 raised to n plus 2 raised to n plus 2 plus 2 raised to n plus 3, it can be written as 2 raised to n plus 2 raised to n multiplied by 2 raised to 2 plus 2 raised to n multiplied by 2 raised to 3. Then by taking out 2 raised to n as common factor, it can be written as 2 raised n multiplied by 1 plus 2 raised to 2 plus 2 raised to 3. Thus it becomes 2 raised to n multiplied by 1 plus 4 plus 8, that is 2 raised to n multiplied by 13. Let us now revise all the formula we have learned so far. Once you get well acquainted with these formula, you can solve any problem on indices. If you have any doubt about any formulae, you can try the formulae using some numericals. If you have doubt about 2 raised m upon n, you can think of 2 raised to 4 upon 2 raised to 2. Then you will immediately realize that it is equal to 2 raised to 4 minus 2. Basically, you have to remember that there are 4 types of indices. 1. Positive indices like a raised to m plus n equal to a raised to m multiplied by a raised to n, etc. 2. Zero index, that is b raised to 0. 3. Negative indices like c raised to minus m equal to 1 slash c raised to m. 4. Reciprocal indices like d raised to 1 slash m equal to square root of d. Let us solve some problems. To solve any expression, 1. First observe it carefully. 2. Here first term is ending with 5, hence it may have power of 5. 3. It is 5 raised to 3. 4. In index 3 appears in denominator. There 3 and 1 upon 3 can cancel out. 5. 9 is 3 raised to 2. Hence 2 and 1 upon 2 can cancel out. 6. First term index is having minus sign, therefore it will shift to denominator. Having made this observations, Now we can proceed to solve. To solve this expression, 1. Shift the term with negative index to denominator. 2. In place of sixth root, write index as 1 upon 6. 3. In place of a raised to 3 raised to 1 upon 6, write it as a raised to 3 multiplied by 1 upon 6. 4. 3 multiplied by 1 upon 6 is equal to 1 upon 2, 5. Now since base is common for all the terms, add all indices in the denominator, 6. From index of numerator. Subtract index of denominator. 7. Therefore a raised to 1 upon 8 is the final answer. We can see that 8 can be expressed as 2 raised to 3, also 125 can be written as 5 raised to 3, therefore it is clear that indices 3 and 1 upon 3 will cancel each other. Now we should check whether 343 can be expressed as cube of some figure. It can be seen that 7 raised to 3 is 343, therefore we can write all these terms as cubes raised to some indices and then cancel out 3 and write 3 multiplied by 1 upon 3 equals 1. It then reduces to 7 plus 2 raised to 2 multiplied by 5 raised to 1 upon 3. This is equal to 7 plus 4 multiplied by 5 raised to 1 upon 3. This becomes cube root of 27 equal to 3. First use the formula a raised to m multiplied by b raised to m is equal to a raised to m. Then use formula a plus b multiplied by a minus b is equal to a square minus b square. Then expression becomes 52 minus 3 raised to 1 upon 2. This means square root of 49 equal to 7, therefore final answer is 7. While dealing with indices, you should remember that index indicates how many times base is multiplied. If you keep this point in your mind, then it will be very easy to remember or verify any law of indices. While solving problem on indices, 1. Shift term with negative index from numerator to denominator or vice versa to make index positive. For example, 2 raised to minus 3 to be written as 1 upon 2 raised to 3. 2. If there is a term with square root or any root, write it as reciprocal index. For example, if there is a term with cube root, then write its index as 1 upon 3. 3. If index of any term is 0, then its value is 1, irrespective of its base. 4. Write all numerical bases with its factors as base and corresponding indices. For example, if there is a term as 36, you can write it as 9 multiplied by 4, that is 3 square multiplied by 2 square. 5. When multiplication of two terms is having an index, do not forget to write index of each term. For example, square of 2a to be written as 4 multiplied by a square, 6. Now you have to simply add the indices with the same base and all multiplying factors. Do sufficient practice to solve problems using above tips. Practice makes you perfect. Speed of solving problems increases. Speed is equally important. Please subscribe to the channel and press bell icon to get notifications of upcoming videos. Also share it with your friends. If you have any difficulty, please feel free to write in comments. So go ahead. Best of luck.